Hello, children. Welcome in Mindflux, where logic is going to connect with the nature, and we people are learning about the nature. A lot of things around us, which tell us a lot of things in the form of some stories, which relates the day-to-day life with the nature. Okay, so basically, in science, we people are studying the nature. So I am a physics teacher, as you know very well. Last time also we have done lecture on the force chapter. I hope you people remember the types of force we have discussed in our previous lecture. And in this current session, now we are going to start about the laws of motion. Okay. So basically, when I talk about the laws of motion, the main person who have given the statements of this from where the concept arrived, the great scientist named as Galileo. So Galileo has done basically in the research in a field of force, and after doing some experiments he found and he made one conclusion that object always remain in their state. Either it will be the state of rest or it will be the state of motion. Okay, so what he has done basically, you can see my ppt on slide. The person is doing the experiment. Okay, in this experiment you can very well see over there, there is some inclined path over there. From one of the side the person is trying to leave the ball, so the height from which the ball has covered, the equal distance has been covered by here on the other side of the inclined plane. So what experiment he has basically done, he was inclined the path, and after some times when the path gets straight, he was just checking whether the ball was covering the same distance or not, and the ball will be going to stop at certain interval of time at some point or not. So many of the questions were arrived. So the ideas came, finally they have made the conclusion, and ideas came like, if the ball is going to receive some force, either it will be in the form of unbalanced force, so the body will do the motion. Okay, so what I said, if the body was at rest, if you want to make it move, so you have to apply the force. Yes, if you want to change the position of the ball, so you have to apply the force. And that force, that external force because of which the body is going to change their position, is called to be what? Unbalanced force, that we have done in our last lecture. Yes, children. Okay, and now in this session we are going to study about that experiments, that how the laws came and what it means, how it affects the state of motion. Everything we are going to see. So the concept, now we are going to start from the first law of motion, which has been given by the Newton. So Newton has continued the concept of Galileo. What Galileo said, to start the body or to stop the body, we obviously need external unbalanced force. Okay, so what Newton has modified the statement. Newton said object will remain in their continuous state, either it will be state of rest or it will be state of motion, unless and until you are not applying any external force. If you apply any external force, the body will change their state. Okay, but if you are not applying any external force, so body will remain in their state. Okay, so basically what we have learned about this situation, the object always try to resist the change. Yes, children. Suppose I am now teaching you. Okay, if some person suddenly entered in my room, and because of that also I am not going to disturb myself, so that means my body is trying to resist the change. I am doing my work continuously in the same way, so it has not affected me. So that means what I am doing, I am doing the resist, I am resisting the change. Yes, so similarly here also, everybody in our nature has capacity to resist the change. If the body get changed, that means the body has received the unbalanced force in any form through the external agent. Okay, so what is the Newton first law? The body will remain in their state or try to maintain their state, either it will be state of rest or it will be state of motion, unless and until it will not receive any external force. Okay, children, so let's move on the next concept. So this was the concept This was the question where the Galileo was stopped and he found the answer. Yes, the ball will stop when we apply unbalanced force on it. Now, the next concept which is arrived, which is also called to be the law of inertia. Newton's first law is also called to be the law of inertia. Why? Because inertia, what it means? Inertia is nothing but what? Everybody have a tendency to resist the change. Okay, so here is also in this room, if you are going to push the wall is not going to change their position. Why? Because ball is trying to maintain their position. Yes, my children. Yes, so if you want to apply, if you want to shift the wall, you have to apply more and more amount of external force that will be greater than the force applied by the wall on your hand. Only in that come the body will move. Yes, we have already done discussion on balance and unbalanced force. So if you want to change the position of the wall, you have to apply more and more amount of force. Or in other case, I can say the body is trying to maintain their position of rest. So I can say the wall is having well tendency to resist the body, to resist the change. Yes. So this concept, this type of tendency where we see the body is maintaining their state of rest, I can say that is the inertia of rest. So in this way, in similar way, we should know there are three types of inertia, and that completely depends on the mass. So mass, you know very well, it's nothing but what content of the body. Children, please do remember there is a huge difference between mass and weight. Weight always relates with the gravity. So we people are comparing with the gravitational force, but mass is related to content. Content always be fixed. So mass of the body is fixed. But if I am going to measure the weight of my body, so according to the gravitational force received on any point on the earth, so it depends on the how far you are or how away from center of the earth, and you are on which position on the earth. Okay, so basically it depends on the distance from the center of the earth to the position of you where you are standing. So if distance is less, the force will be more. Yes, so gravity will be more. Are you getting? Yes, so there is a difference. We'll continue that concept in next chapter, in gravitation chapter, don't worry. So for time being, you just remember everybody is having definite different mass, I can say definite mass, that will not be going to change. So if you are going to compare between massive body, high massive body and low massive body, so obviously the more massive body is having high tendency to resist the change. So there are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. So if I say tendency of body to oppose any change of state of rest, so it will call inertia of rest. Inertia of motion, similarly, if the body is already in motion, if you are driving a car, you are already in motion, and suddenly speed breaker arrive in front of you, so obviously your motion got interrupt because you have applied brake. Yes, so that means you are actually trying to maintain the changing the position, but that is what at that time you can say inertia was not there because your body is got to be changed. But if something happen, if some person is trying to abrupt your path, if some person wants to disturb you so that you can make change in your journey, but suppose you are not changing your path, you are moving constantly with the particular speed, or you are maintaining your uniform motion, so at that time I can say the body is in uniform motion. That means body is having well tendency to maintain their position of motion, their state of motion. Yes, so tendency of body to oppose any change in a state of uniform motion is called inertia of motion. Yes. Now next concept is what? Inertia of direction. Suppose anyone is trying to change your direction, you are in a motion, but you are not giving attention to that person, and you are making your effort and you are continuously in your motion. So that means you are trying to maintain your position. So that means you are trying to maintain your direction, you are moving in a continuously single direction. Yes, so this tendency of body to oppose any change in its direction of motion is called inertia of direction. आसान भाषा में यस चिल्ड्रन, आप ये भी बोल सकते हो। डे टू डे लाइफ में बहुत सारे एक्सपीरियंसेस है। फॉर एग्जाम्पल, इफ यू आर सिटिंग इन अ कार, इफ कार इज एट द रेस्ट, okay, if car is at the rest, so at that time suddenly if car is going to start by the driver, so you feel jerk, your body move in backward direction, right? so होता क्या है कि जब कार आपकी जो लोअर पार्ट ऑफ द बॉडी है दैट इज इन अ कांटेक्ट विद द सीट ऑफ द कार, तो वो ज्यादा अफेक्ट नहीं करेगा। लेकिन आप देखोगे अपर पार्ट ऑफ द बॉडी है, सो वो बैक साइड फोर्स फील करता है। क्यों? क्योंकि कार क्या थी, रेस्ट में थी, तो उसके पहले आपकी बॉडी भी रेस्ट में थी। बट जैसे ही कार स्टार्ट हुई एंड you are car is moving in a forward direction, so your lower part of the body is not going to affect because lower part of the body is in contact with the seat of the car, correct? But your upper part of the body which were not in the contact with the seat of the car, that will definitely affect, right? so इस वजह से आप किस साइड, किस कौन से डायरेक्शन में बैक साइड मूव करते हो, यू आर मूविंग इन अ बैक साइड डायरेक्शन। बट सपोज car is in motion and sudden brake is going to apply by the driver, so at that time you feel jerk and your upper part of the body move in a forward direction because तुम्हारी बॉडी क्या कर रही थी, एक सिंगल डायरेक्शन को मेंटेन कर रही थी। यस, कॉन्स्टेंटली अपने पोजीशन को बनाए रख रही थी। सो वहां पे इनर्शिया ऑफ डायरेक्शन भी आ गया, इनर्शिया ऑफ मोशन भी आ गया। जब तक ब्रेक नहीं लगाया था आपकी बॉडी में कौन कौन से टाइप ऑफ इनर्शिया थे, इनर्शिया ऑफ मोशन एंड इनर्शिया ऑफ direction. So I can say inertia of motion and inertia of direction is nothing but one. In both the case your body was trying to maintain the motion, yes, avoiding the change, tendency of body to maintain the type of motion and tendency of body to maintain the direction. Yes, you can see children, here we have shown on the screen one of the activity. You can see clearly we have compared with the types of body. There are two different types of body you can see, and different types of inertia we have discussed here. This person is having less mass as compared to the elephant. Obviously elephant is having more mass. So what things you people are seeing over there? Elephant is trying to maintain their position, that is a state of rest. Yes or no? So it is having more tendency to make the position, to make the tendency. So here we can say more inertia of the body is there. So that's what relation we got here. I can say children over there, if mass is more, your body inertia is more. So I can say inertia always be directly depending on mass. So what things we have arrived? So we arrived on the concept here. We can say inertia of body always be directly proportional to mass. Yes, so first thing we have studied today. And inertia, the law of inertia also called to be what, or vice versa? Newton's first law, right? Three types of inertia we have studied: inertia of rest, yes, inertia of motion, and inertia of direction. Yes children, okay. So you can see here in this activity also, this driver wala activity, the driver is driving the car. Yes, it is maintaining the position as the signal came. So again he, yeah, press the brake button. So after that what happened? Yeah, the motion got abrupt. Yes, and in this position the body is trying to maintain their state of motion, and because of that condition we people are feeling jerk sometimes if sudden brake if you are applying. Let's move on to the next concept, that is called momentum. Momentum, what it means? Some children are always gives definition as momentum is nothing but what, product of mass and velocity. But actually beta, momentum means what? It always measures the motion, the quantity of motion possessed by a body. And obviously if we are going to measure the motion of the body, that means we people are measuring the force with respect to time. So rate of measurement of force is gives to you what, quantity of motion possessed by a body. Yes, Yes, children. So again, here we are going to consider the mathematical concepts scalar and vector. If you are calculating something, if you are measuring something, so that will be represented by magnitude. And if you are following direction also along with the magnitude, you are measuring something and you are moving in a particular direction, so that will call to be what? Vector quantity. So vector is nothing but what? Where you are considering magnitude as well as direction. So this momentum is nothing but what? If you are applying force, and because of that force your body is doing motion, so quantity of force applied, how you are measuring? In the form of motion. Yes, so that concept is called to be what? Momentum. Now it will be linear kind of motion, so that's what we are representing in the form of small p. So small p is what? Product of mass and velocity. And obviously if we are going to substitute, if we are going to substitute, p is what? M into v. If we write the unit of mass, so it will be SI unit is kg, and velocity is what? Meter per second. So our momentum, linear momentum, which has been represented by small p, represented by the unit kilogram meter per second, and obviously it is what? Vector quantity. Okay, so in this video only we are going to discuss about the momentum and Newton's first law. In our next video, we are going to continue with the Newton's second law of motion. For time being, I am saying goodbye to you. Enjoy. We'll continue with the next lecture tomorrow. Okay, children. Bye bye. Have a nice day ahead.